provide an acceptable name. This is 2-bromo-3,3,4-trimethylpentane. Newly isolated natural product was found to have this chemical formula here. By hydrogenating a sample of this, it was determined to possess 1 pi bond. How many rings are present? So we do our usual thing for 15 carbons. If it's fully saturated, that would be 32 hydrogens. We have 28. That's a difference of 4 dividing by 2. That means there's 2 elements of saturations. Elements of saturations are caused by rings or pi bonds. Burn one up with the pi bond. That leaves room for 1 ring. Does that make sense? 1 ring has 1 ring and 1 pi bond. 2 elements of unsaturation. Provide a correct IUPAC name for the structure below. This is a diene, and we're supposed to give the double bonds the lowest numbers. So once we choose to go through a double bond, we can either start at this double bond or this double bond here. Since we have this substituent, we got to go around this way, which makes that bromine have a 5. So this is 5-bromo-2-methyl 1,3-cyclopentadiene. Or you can put the 1,3 hyphenated here in between the A and the D.
Yeah.
Alright, this thing here is the same side for priority, so we say Z5-fluorylpenta-2-ene. Translate the following condensed structure into a line angle structure. Got this E here, comes out looking like this. Alright, this thing here, chlorine has higher priority over the methyl. This carbon chain mass has priority over the hydrogen that's there, so this is Z. See, I graded easy. Normally I count half off. Stereochemistry is missing. I love stereochemistry. And so do students. If I can smile and act positive enough about it, I'll brainwash them. Give an example of a corrosive solvent, methanol, ethanol, water. Here's an alkene. Here's an electrophile. This thing's going to hit, and the rich is going to get the hydrogen. You're going to have a secondary carbocation. It's going to rearrange into a tertiary. And so here's the addition product. Which of the following is the strongest nucleophile in aqueous solution? That would be iodine. Here is the anti-Makarnikov hydration of a double bond reagents. So that's going to put the OH there. Unfortunately, I didn't give you any rings to show the Sn addition nature of this, but I think you got that on a quiz. Probably might get it on the final. Addition of bromine to E-hex-3-diene gives. Thank you. So the way to figure it out, and this is kind of what I told you in lecture when we went over that thing on the slide. We had like 2 different alkenes. And this one, when you realize that this is a anti-addition event, or it's anti-addition, this one's super easy when it's the Z isomer because there's the anti-business, and you're already kind of like in a Fisher projection, is where all the stereochemistry is. Now this thing, we could probably imagine one being on one side, one being on the other, and then when we roll that around to get it into a Fisher type projection, we're going to see the bromines all on one side. There is a mirror plane, so this is a meso-dibromide. Draw the major organic product generated in the reaction below. Pay particular attention to regio and stereochemical detail. Must be a class of introverts, because some classes, students come up and they ask me questions during the exam. A good question might be, is this solvent or reagent? And I'd probably be like, well, I think it's solvent. So don't go stick it anywhere on the molecule. You want to say, oh, this is bromination of an alkene. It's an anti-addition event. You're going to get this, and it's an anti. Any questions on that first page? True statement about the transition state of a Sn2 reaction is the single transition state represents the point of maximum free energy during the reaction. Probably all the rest are faulty or don't make any sense. Which of the following alkylides is likely to undergo rearrangement in an Sn1 reaction? So there's the 3-bromo. Here's this. This one here will undergo a methyl shift. So you want B there. Draw all likely alkenes. A lot of people were so excited to get to the last page where they make the predictions, and they made predictions, and they didn't even read alkene. And both these. So both of these were this concept here, the difference between the Hofmann and the Zadev's product. Bulky bases, slender bases, big deal. Probably see this on the final. It's half comprehensive or a portion comprehensive. So slender base, tertiary, no Sn2 with a tertiary substrate. Here's the two alkenes, and you want the more highly substituted. All right, what is the molecular formula of a hydrocarbon that contains 8 carbon, 1 ring, pi bond? So 8 carbons, 8 twice is 16, 2 more is 18, and then go 1 ring, 2 pi bonds, sums up to 6, subtract 6 from that. This is our degrees of unsaturation. Should get that. Alright, a hydrocarbon with a molecular formula here has how many elements of unsaturation or degrees of substitution? 20 twice is 40, and 42. 42 minus 34 is 8. 8 divided by 2 is 4. 4 degrees, or 4 elements of unsaturation. Alright, here's the same thing. You wanted to read this alkane and not give me any substitution products. However, tertiary alkyl halides do not undergo Sn2. So this one's bulky. So the base pulls a hydrogen off of here, and you get the Hofmann product. Alright, here is a alkyl sulfide. It's on the strong side as far as nucleophiles go, but a strong nucleophile does not also mean a strong base. Most strong bases are strong nucleophiles, but not every strong nucleophile is a strong base. So what occurs here? Sn2 occurs, and we get an inverted stereocenter. Provide the structure of E3,4-dimethyl-3-heptene. That's going to look like this. Provide an IUPAC name for this. Looks like high priority low, high, low. It's going to be E. This is going to be, down here, one of these methyls is the end of the chain, the other is a substituent. So we get 3,5-dimethyl-hex-2-ene. Once again, half pointed. This thing here does not possess geometric isomerism. Provide the systematic compound shown below. This would be Z4-fluoro-3-heptene. Name the compound below. This looks like a Z event. This looks like an E event. Looks like we want to start the chain here. So this is going to become 2E4Z 7-fluoryl 2,4-heptadiene. Of course, you can put the 2,4 right in there if you like. IUPAC. Circle all that apply, 1 point each. Works best with bulky base. B2 requires anti-periplanar geometry. That's E2. Mechanism involves carbocation. That's only the unimolecular Sn1 E2. Mechanism has 2 steps. That's once again the unimolecular. Rate increases with a better leaving group. That's all of them. Some of them's not as critical as others. Stereochemistry is inverted. That is the Sn2. Zadev's product is formed. That's an elimination deal. Any elimination, doesn't matter which type. Rate increases with concentration of the substrate. That's all of them. Rate increases in aperiodic solvent. That is Sn2. I doubled up on this. I just crossed that out, so you got it right regardless. When 1-bromo, 1-methylcyclohexane is heated in ethanol, extended period products result. Draw the structure product or alkene products. I think I gave you a quiz with something very similar. I don't know if the extra credit. I think it was the extra credit on the take home. Was it on your note card?
Yeah.
35, 36, 37.
Yeah.
You got good 66% partial credit. Something must have been jacked up. Sorry. And you didn't need the mechanism, but you needed the 2 alkenes and the Zadev's product. Alright, once again, a lot of people failed to read this word right here, alkene product. So the interesting thing about this, in E2 elimination, the hydrogen comes off an adjacent carbon to the bromine, and there's none there because you got a quaternary carbon. So this one comes off, it's got to put the double bond there. Alright, for each of the reactions below, write the chemical reagent needed above the arrow. So here, primary and an OH. So we got to do Sn2 substitution. We want hydroxide. Primary, alkene, bulky base would work best. Here, we see inversion of the stereocenter and we see substitute. We want to choose OH. Some of that forms, but doesn't matter with the question. You want to put OH. And here you probably got full credit if you put OH as well. Bulky bases work a little better. Here, inversion of the stereocenter, we got the secondary. The secondaries are the worst because they can do unimolecular and bimolecular. Oh, I was going to be done by 11:30. All right, tertiary, bulky base, we can only do E2, can't do Sn2. Tertiary, weak nucleophile, so Sn1, E1. This is probably going to predominate. Tertiary, no Sn2 can occur. Strong base, this is going to be your product. This one was the worst one as far as, I don't like it, but you got to go with it. We got a tertiary. They don't like to do Sn2. We have a strong nucleophile, not a strong base. So if you gave me this product, I went easy on the partial credit, but here's really what you want. Once again, cyanide's a strong nucleophile, but it's a weak base. So we just really only want the substitution product, and we get stereoinversion. So secondary alkyl halide, weak nucleophile, we're going to get these. You probably get a little more of the substitution than the elimination, because what type of base is ethanol? Not much of a base. Cyanide, strong nucleophile, not a strong base. We want the substitution. And if you see stereochemistry, that sometimes means you want to write this down. So here's the crazy looking thing, water. It's got to be unimolecular. I gave you credit for either, didn't matter which one. Secondary alkyl halide, bulky base is predominantly what happens. You're not going to see much substance. This is bulky. Strong nuke, strong base. Didn't matter which one. Thank you. Let me start over. Primary alkyl halide, strong base. Both these could happen, and I gave you full credit regardless of which ones you did. Any questions? Yeah, but it's always